you give them 10 times the dose for that particular animal. All right. As you use the metric system more and more and more, you never have to convert. That's the beauty of it. You know, right now, because this country hasn't really made it a ship, we all have to learn these things like, you know, how to convert back and forth, because some people absolutely will refuse to think in the metric system. And, you know, I have a couple of tape measures at home, and they're all in inches and feet, right? And a lot of things are just like that. There's one more thing that we measure in science and in healthcare that's pretty important, and that is temperature. Okay? Temperature. So, we call it the centigrade system, right? That's the metric system of temperatures. And there's formulas that you can learn, and you will learn them 1,000 times, but you will forget them 1,000 times, okay, to convert between Fahrenheit and centigrade, and between centigrade and Fahrenheit. So I'm going to teach you how to do this so that you will never, ever forget it. How's that for you? Okay? All right. Well, first of all, let's talk about Dr. Fahrenheit. Because Dr. Fahrenheit was a scientist kind of guy, and he made himself a thermometer. And that thermometer was a long piece of glass, and it had a little empty space down the middle and a bulb on the bottom, and he filled it up with mercury, I think. And then he put some numbers on the side of it, and he said, well, now that I've got this wonderful thermometer, I need to come up with a system. And so he stuck that thermometer in a glass of ice water. And he swirled it around for a while. And it came up to this number that just so happened to be 32. And he said, oh, that's cool. Freezing is 32. And then he took his same thermometer and he stuck it in a boiling thing of water, and he read the number off the side of his one and only thermometer, and it said 212, yes. See, all of you didn't even know it, right? Okay. So 32 goes up to 212. So this is boil, and this is freeze. Okay? Now, let's just say there's a bunch of lines across here that measured all those numbers up there. How many lines are there between 32 and 212? 180. Man, he's got a calculator. That's right. 180. So there's 180 Fahrenheit degrees between freezing and between boiling. Well, these smart guys that gathered in France that one time, they said, you know what? If his thermometer had been a little bit different, it might have been 192 degrees between the two of them, or it might have been 42 degrees between the two of them. Let's standardize things. And let's say we're going to make a new system, and freezing is going to be 0. What a smart idea. And let's say that boiling is going to be 100. Okay. So, how many lines have they got between the two? 100. Okay, so between here and here is 100 degrees. Does anybody notice anything interesting between 180 and 100? This is where the real luck came in for Mr. Fahrenheit. The luck is that if you reduce these two numbers, 180 over 100, they reduce to 9 over 5. Okay? And what that means is that for every 9 of these Fahrenheit lines, there's 5 of these centigrade lines. Does that make sense? So which degree is bigger?
Celsius.
The centigrade, the Celsius degrees are bigger. Okay? All right. So how do we convert between the two of them?
Well, you can use that as a conversion factor, right? So you have like.
Yeah, you can use that 9/5 or that 5/9 as a conversion factor. Very good. But what else have you got to do to make the conversion right? Huh? You've either got to add 32 or you've got to subtract 32, right? So if you're going from Fahrenheit to centigrade, you've not only got to multiply it by 5/9 because these are bigger, but then you've got to subtract 32 because remember this one started out at 32. That is all there is to it. So the formula, the conversion factors, which like I said you can memorize, but I know you won't remember them, but like you'll see in the books, to convert degrees centigrade to degrees Fahrenheit, you take the centigrade, so that you take the centigrade degrees, and they're bigger, right? So you're going to multiply them by 9/5 to get the degrees Fahrenheit plus 32, right? So that's one of the formulas that you'll see in your books, but that explains why it works that way. And the other one would be, to convert the other way, you can do the Fahrenheit degrees times 5/9 minus 32, right? Now, let's talk practical temperatures, because it doesn't really mean anything unless you know how you're going to use it. What's the temperature in this room, you figure? Let's say it's 72 degrees. Okay, that's what normal room temperature is supposed to be, 72. All right, so what is that in centigrade?
Well, it would be 72 times 5/9 minus 32.
Very good. And it would be 25, about 25. Okay, so room temperature, I'm going to just write you a few temperatures here that I truly believe you ought to know. Room temperature is usually 72 or 25. We know that freezing is 32 or 0, right? And we know that boiling is 212 or 100. But there's really only one other temperature that I know that we measure much of, and that's body temperature. So what is your body temperature in Fahrenheit? 98.6. There used to be a song back in the 80s. Hey, 98.6, I'd love to. You remember it? Few of you? Only the older ones. All right, so normal body temperature is 98.6. What is that in centigrade? 37. That's right, 37. Well, here's what would happen to me. I'd be laying in bed, sleeping very nicely at night, and the phone would ring, and I'd pick up the phone, and the nurse would say, Dr. Sessions, Mrs. Jones has got a temperature of 39.9. And I'm like, wow, she's really cold. And I would say, well, what is that in Fahrenheit? That's what I said at first, and I hated looking stupid, so I did come up with a conversion for myself. And here's what I came up with. If 30 patients' temperatures generally go between 37 and, say, 104. 104 is pretty big time temperature, right? So therefore, 37 is 98.6. I'm sorry, I wrote this wrong. 37 and 40. which is between 98.6 and 104. So the only other conversion factor I know is that if you've got a temperature of 104, that is 40 degrees centigrade. So when they would call me and say, well, it's 39.2, I would think, that's pretty good fever, but it's not 104, you know. And so that's the only two I knew, but they worked okay for me, and probably will for you too. So 4 temperatures to know: freezing, boiling, normal body temperature 37, pretty good fever 104. Now I bet dogs and cats probably don't run 98.6, do they?
A little higher, or yeah.
100 to 102.5.
Okay, so they're a little bit higher, but you can still still get that what I'm talking about.
We can still
there.
consider 104 to be a significant temperature.
Yeah.
Yeah.
Now the other way to cheat is to have one of these little thermometers like this that has one on one side and one on the other. I suspect it'll be a long time before these disappear in America. How much volume is this? 1 liter. That's right. This is 1,000 cc's. Okay. Now, one of the other things that you need to have a conversion factor on is your drips, because you don't give IV fluid usually with a syringe, you know, a cc at a time. Here's a cc syringe, and this one measures down to 1/100th of a cc, so that's pretty accurate for very small volumes. On the other hand, I've got some bigger ones here that probably ended up in my pocket. Oh yeah, here we go. There's a 20 cc syringe, okay? Once again, each line on this is 1 cc. Each line on this is that much volume. 1 centimeter by 1 centimeter by 1 centimeter. A cubic centimeter, a cc, other name, a milliliter, 1,000th of a liter. And indeed, if I had 1,000 of these little guys like that, I could put 1,000 of them in that liter box right there, and it would fill them right up. Okay? So yeah, this is a liter, and most drip kits will have a number on them, and it'll say how many drips per cc. So that's a little conversion that you'll need to make sometimes. If you're supposed to give 50 cc's an hour, for example, you can figure out how many drips that is per minute. How many minutes are there in an hour? Yeah. The other unit of measurement in the world is time, and time is the same. The metric system did not find a new system for time. So they still use seconds, minutes, hours, days, leap years. You know, they still have to throw in that leap year day every 4 years to keep us in the right season after a few years. Okay? What do I think you need to memorize and know for sure? No hard and cold. You need to know the prefixes. Everything from nano, micro, milli, centi, deci, deca, hecto, kilo, and mega. You need to know those because you will see them all the time. And then you just need to understand that the unit of volume is always the liter. You can go up or down from that. The weight, grams, can go up or down for that. And the length is a meter, is the stick, which is 1/10,000,000th of the way from the equator to the North Pole. Okay, now, I'm going to give them a homework assignment. In America, if you go out to a running track, okay, every running track in Multnomah and Washington County is what length?
400 meters.
Somebody said a quarter mile.
400 meters.
Somebody said 400 meters. The answer is 400 meters. Every track in the United States has been converted to a 400-meter track. Now, why did they do that? Because the international competitive bodies of track and field said, we're going to throw out all those old English measurements. So the 100-yard dash, you cannot compete in the 100-yard dash anywhere in the world today. You cannot compete in the 220. It used to be the 220 and the 440, which was the quarter mile, because the old tracks used to be 440 yards around, which was a quarter mile. Which one's longer? That's what you got to figure out. And tell Brad next week sometime. Okay? Which track is longer, a 400-meter track or a 440-yard track?
Okay.
And I would also tell you that there is no such thing anymore as, like I just said, there are no English units for races except for one. There is one race that is still measured in the English system. The mile. The mile run is so classic that they still run the mile run. They don't run it in the Olympics anymore. But what they do run is what we call the metric mile. Okay? And anybody know what the metric mile is? Excuse me? 1,500 meters. Now think about that one for a minute. 1,500 meters on a 400-meter track. Huh. So it's not 4 times all around, because that'd be 1,600 meters. So they actually start the race down the track about a quarter of the way around, and they run from there and then finish at this point. Okay? To run the 1,500 meters. But the reason they chose that number, first of all, it's halfway between 1,000 meters and 2,000 meters. But second of all, it's pretty close to the old mile run. And my next question then is, which is longer? The mile or the metric mile? Really? You'll have to prove that to me with numbers and a couple of conversion factors. Last thing to think about is, I want you to all look at your speedometer on your car. When you go home tonight, especially if you have one of those old things that goes around like this, it tells you how fast you're going. And you probably notice that there's 2 sets of numbers. There's a little set of numbers inside, and then there's a bigger set of numbers on the outside. And the bigger set of numbers usually goes from 0 to like 180. And the little set of numbers on the inside goes from 0 to like 240 or so. One of them is metric, and one of them is English. So one of them is miles per hour, and the other one is kilometers per hour. That's right. Now, we had started to make the changes in all the speed limit signs in America back in '75, and the speed limit said 100 kilometers an hour. Boy, a lot of guys say, hey, that's great, I can go 100. Well, you can go 100, but it's 100 kilometers an hour. Off the cuff, if you're going 100 kilometers an hour, how fast are you going? 62 miles an hour, 6.2, remember we said 10K, 6.2 miles. Okay. That's all I got. Any questions?
Thanks, Dr. Sessions.
Yeah.
Good job.